Hey guys, I'm Ian Bishop, and today I'm going to be teaching you about Euclid and his method of geometry, Euclidean geometry. So, I know Euclidean geometry may sound a little bit intimidating, but it's really not, and you've all done it before. Before we can start learning about Euclidean geometry, though, we need to learn a little bit about Euclid himself. The issue with that is that, besides his work, there's no real references to Euclid's life at all in history that survived. So, besides, I think it's 2 references from other people's work, nothing really exists about Euclid. What we know is that Euclid was born in Alexandria, Egypt at some point in the middle of the 4th century BC, part of the Hellenistic period, which is the period of Greek history after the death of Alexander the Great, but before the rise of the Roman Empire. The fact that he was born in Alexandria is vitally important, because at this time, Alexandria was one of the most important centers for learning in the world. It attracted scholars from all over to come and study. I think the best way to think about Alexandria at this point of time is like a big citywide university. It was a melting pot of knowledge and culture, which allowed for great advancements in all fields of science, fine arts, and mathematics. There's not much beyond this, though. We don't know much about Euclid's life because it didn't survive, and I'm sure that you could go scouring for little trivial facts, but those aren't going to help us at this point. Those won't help us understand how Euclid got his background in mathematics. As a Greek mathematician, there are a few more inferences we can make about Euclid's life based on the position of Greece in the world at this time. So during this time, Greek society is peaked. They're experiencing a time of great development in all fields of art, sciences, and mathematics. This was due to the previous conquering of many lands by Alexander the Great. An empire this size had no trouble progressing, what with the sheer number of scholars that they had at their disposal, and they all had differing backgrounds both culturally and academically. As a mathematician, Euclid was very interested in the idea of geometry, hence Euclidean geometry. And no, it's not some fancy geometry you won't understand, it's literally just geometry. Euclid was fascinated with lines, planes, and other geometric figures, and set out to compile all the information he could find and prove it to figure out just what made geometry tick. After compiling and synthesizing all of this mathematical info he could find, he then set out to prove it, and published a book called The Elements. Now, when he first developed it, it was just referred to as geometry, not Euclidean geometry, because no other forms of geometry had been invented at this point, and they wouldn't be until the 19th century. While others had proposed the ideas Euclid explains in his book, he was the first to combine them all into one system of mathematics. Something that's interesting is that Euclid himself actually didn't make too many discoveries, but rather just developed proofs for the ideas that other people had proposed, and showed how they worked together. This synthesis of geometric ideas was earth-breaking at the time. To this day, most geometry is based on Euclidean geometry and the points that he put out in his book, The Elements. Euclidean geometry is the basic point into line, into plane, into solid geometric shape that you all know. The ideas of Euclid are taught at both the middle school and high school levels, and his book basically translates algebra into geometric terms. If you ever took a high school geometry class, chances are it was almost entirely Euclidean geometry. In Book 1 of The Elements, Euclid refers to the Pythagorean theorem, a mathematical technique discovered by Pythagoras, and presents us with a proof of it. The Pythagorean theorem states that in any given right triangle, the square of the longest side is equal to the sums of the squares of the other 2 legs. Basically, a squared plus b squared equals c squared. So an example of this would be this. Alright, so for the Pythagorean theorem, obviously it's only going to apply to right triangles. The first thing we're going to do is we're going to make a right triangle. Now, this obviously isn't going to be to scale, just because I'm just sketching it out right now. But let's say that with this right triangle, you have this length, this left side is going to be a length of 5. I'm going to excuse my bad handwriting. It is hard to draw with a mouse. So for this longer side down here, this longer leg, I'm going to give that a side of 12. Now, what we don't know is here, which is x. So in order to so the Pythagorean theorem is going to tell us that a squared plus b squared equals c squared. So this squared plus 12 squared, so 5 squared plus 12 squared is going to equal x squared. So basically what you're going to do is you're going to make that into an equation like this. And then that's going to be 5 squared is 25 plus 144, which is going to equal still x squared. What you're going to do, you add these together, you get 1, that is not a 6. You get 169 equals x squared. You're going to take the square root of both sides. And what you're going to get is 13 equals x, which means this side, whoa, that was a really bad arrow. That side is going to have a length of 13. Now, that turned out really easy. And I got a really easy number because like I got an easy whole number. It wasn't a decimal or anything, because what this set of numbers is, it's called a Pythagorean so like 5 and 12 and 13 are what's called a Pythagorean triple, so that so they'll always work out into whole integers, if that makes sense. Another example of Euclidean geometry is the triangle angle sum, or the idea that all of triangles' angles would have to add up to equal 180 degrees. Knowing this, it becomes easy to calculate an unknown third angle in the triangle by simple subtraction. Here's another example. Alright, so what we're going to do right now is, this is my example for the triangle angle sum theorem. So that states that all the interior angles of a triangle are going to equal 180 degrees. So let me just get a triangle here real quick. Yeah, let's go like that. Okay, so I'm gonna say that this lower right angle is gonna be a 70-degree angle. And let's actually just make these sides be the same length, so that we know that that's what this symbol means. Like if like they're not good, but like if it's just like a straight line between two sides, those sides are the same. If there's 2 on the line and there's 2 on another line, those sides are the same length. So if I make those the same, then I can make this down here be 70 as well. I didn't need to do that to make this 70, but I mean, I just did. All right, so then we don't know what that is, so that's x. So the triangle angle sum theorem says that all of these angles in a triangle have to equal 180. So a plus b plus c equals 180. So this is super simple, because all you have to do is, like, if this is, let's not make that x. Let's not make that x. Let's make that c. So that this is a, and this is b, and this is c up here. So then basically what you do is you'll go 70 plus 70 plus c equals 180. So then what you can actually do, like, you can just subtract each from 180 one at a time, but I'm just going to add them to 140 plus c equals 180. And then I can just go c equals 180 minus 140. And then you find out that c equals 40. So this right here is a 40-degree angle. It's I don't think it's too complicated. I mean, it's just basic addition and subtraction. You could get into it. You could get into it a little more in depth, where it's like, oh, this side is 70, and this side is c plus 30, and this is c. So it would be 70. So then the way to do that would just be like 70 plus C, plus, I guess you could do plus 2C plus 30 equals 180. 2C equals 80 because 70 and 30 is 100, so then you can subtract 100. That's how you get 80. And then you just go down here, divide by 2, and then you see it's still C equals 40. All right. Now, I know I just brushed the surface of Euclidean geometry, and it might seem like I didn't go over a lot, but if you want to learn a little bit more, you can click anywhere on the screen right now, and it'll take you to a Khan Academy video that'll teach you the basics of geometry and a little bit more on the history of geometry. Like I said, it may seem like I didn't cover a lot in this video, but that's because we don't know a lot about Euclid himself, and Euclidean geometry is such a large topic that it would be impossible to cover every single piece of it in just one video.